All right, so we're going to look at section 2, and it's all about normal distributions. We're going to split this into 2 days. So the first day is just kind of an introduction to what normal distributions are. So it's just a type of density curve. They're all symmetric, they're single-peaked, and they're bell-shaped. We usually describe a normal curve by its mean, mu, and standard deviation, sigma. We call them normal because they're special, not because they're typical. And we can abbreviate a normal distribution with a capital N, and then in the parentheses, like a coordinate point, the first number would be the mean, and the second number would be the standard deviation. I've got 2 examples of normal distributions. As you can see, if the data is really concentrated around the mean, like the one on the right, our standard deviation is small, so it's kind of higher peaked than the one on the left, where the data is kind of more spread out, so we have a larger standard deviation. So the rule for normal distributions is called the empirical rule, and sometimes we call it the 68, 95, 99.7 rule. But what this says is that 68% of all observations fall within one standard deviation of the mean. And this only applies to normal curves. It's not all density curves. They have to be normal. About 95% of the observations fall within 2 standard deviations of the mean. And 99.7% of the observations will fall within 3 standard deviations of the mean. So let's take a look at what a picture of this looks like. As you can see, it's 1 standard deviation to the left and the right. So the lighter blue would be including 68% of the data. And then the next shade darker, you've got 2 standard deviations to the left and 2 to the right. And from the center, and then to the left and to the right would be 95% of the data. And then the darker blue on the outside, 3 to the left and 3 to the right, all of that would be 99.7% of our data. So here's an example. This is the Iowa Test of Basic Skills for 7th graders, and in the instructions it tells us it's a normal curve because it's using that abbreviation. It's got the capital N and then what looks like a coordinate point, but really the first number represents the mean, the second number represents the standard deviation. So if we were going to draw a sketch of this, we would draw a sketch of a bell curve. The mean would go exactly in the middle. Then we would add 1.55 to the mean 3 times to get the places where the standard deviations would fall. And then we would subtract it 3 times to go to the left. So I'm going to scroll down so you can see what this looks like. So 6.84 is right there in the middle. If you add 1.55, you get 8.39. If you add 1.55 again, you get 9.94. And then a third time, you get 11.49. Then if we start back at the mean 6.84 and we subtract 1.55, we're going to get the 5.29. Subtract a second time, 3.74, and then a third time to get 2.19. And so this kind of just gives us a sketch of the normal curve for this problem. So look at the first example, the first question after we've sketched. It says, what percent of ITBS vocab scores are less than 3.74? Anytime you're asked for a percentage, you're looking for the area under the curve. So the best thing to do is to draw a sketch of this and shade in the area that we're looking for. So it looks something like this. I would draw a line at 3.74 and then shade to the left because I'm looking for the percentage that falls below 3.74. So based on the empirical rule, I'm going to break up the curve to find the percentages. Well, I know that my mean is exactly in the middle, so 50% will fall to the right of my mean. I also know that 3.74 is 2 standard deviations away from my mean. And 95% of my data falls within 2 standard deviations. However, 3.74 is only one direction. So if I'm looking for that area, I would have to divide 95 by 2. So the yellow area is 47.5, the red area is 50%. So if I'm going to try and find the green, what I'm looking for, the whole curve is 100%. So I would need to subtract these from 1. So 1 minus 0.5 minus 0.475 would give me 0.025. So the green area is 2.5%. Therefore, 2.5% of 7th graders fall below 3.74. Let's look at the second question. It says what percent of those scores are between 5.29 and 9.94. If you want to try it on your own, go ahead and pause the video. If you're still a little unsure, we can work through it together. So the first thing I'm going to do is going to draw the sketch. I'm going to draw a line at 5.29 and 9.94, and I'm going to shade between them. So this is the area I'm looking for. Well, I'm going to break up each side. The first side is 1 standard deviation, or I should say the left side is 1 standard deviation. The right side is 2 standard deviations. So I can break it up. The left side is half of 68. The right side is half of 95.2. And then I could just add those two percentages together. So 34 plus 47.5 is 81.5%. So 81.5% of 7th graders have a score between 5.29 and 9.94. Go ahead and try to check your understanding on page 114, and then we can go over these. So here's the answers. Number 1 just asked you to draw the sketch. The mean 64.5 goes in the middle, and then we add the standard deviation to the right and subtract it to the left. The second one wanted the percentage greater than 67, so you can kind of see what I've shaded there, and that was 16%. You can look at how I came up with those numbers as well. And then the bottom one wanted it between 62 and 72, and so you can see my math as well. It was 84%. So the next thing I want to talk about is the standard normal distribution. So if we were to standardize every single value in our data, so we learned how to standardize using the Z formula that you see up there. We learned how to do that in section 1. So if we were to do that for every single value, then we would get the standard normal distribution. And so the mean would be 0, because if you take the mean value and subtract the mean, it's going to be 0. And then the numbers at the bottom represent the standard deviation. In this case would be 1. So numbers that fall 1 standard deviation away would fall at 1. So if we have a standard normal distribution, we can use the standard normal table, and you can actually find this in the back of your textbook. It's called Table A, and it gives a list of areas under the standard normal curve. So the empirical rule is good when data falls exactly 1 standard deviation away or 2 standard deviations away. But what if something falls 0.75 standard deviations away or 1.5 standard deviations away? Because the data is more concentrated around the mean than it is in the tails, we can't just divide those areas in half. Well, the only way you can split it in half is if it's split at the mean. If it's split on the right side, then we're going to actually have to use the standard normal curve. So if you flip to the back of your book, you can kind of take a look at it. I've got a little section right here that I can show you. So it says, suppose we want to find the proportion of observations from the standard normal distribution that are less than 0.81. So on the table A, on the left side, it has the first decimal place. So you would find the 0.8, and then you would go all the way over till you found the second decimal place, in this case 1. So 0.81, and where they meet is the area under the curve, 0.7910. I'll go ahead and tell you that this table only does less than. So if you wanted greater than 0.81, you would have to subtract that area from 1. So this area is 0.7910. But if you wanted to know z greater than 0.81, we would subtract that from 1. So 1 minus 0.791. And we could get the area to the right. So just keep in mind that the area on the table is always to the left, and we have to subtract from 1 to get the area to the right. Let's look at this a little bit more. So here's the standard normal curve. It says, suppose we wanted to find the proportion of observations from the standard normal distribution that are greater than negative 1.78. First thing you want to do is shade this area. Negative 1.78, greater than would be shaded to the right. So then we would need to go to our table. We'd have to find negative 1.7 and then go over to the 0.08. So there's negative 1.7. We go all the way over to 0.08, and where it meets is 0.0375. Since this is to the left and we're looking for greater than, we need to subtract it from 1. So the final answer is 0.9625, or 96.3%. So 96.3% of the data falls above negative 1.78. So let's look at another example. It says find the proportion of observations from the standard normal distribution that are between negative 1.25 and 0.81. So if I draw this, negative 1.25 is about right here, and 0.81 is about right here. So I'm not less than or greater than, I'm between. This is a little bit trickier. You're going to have to find two areas under the curve. The first one is going to be less than 0.81. The second one would be less than negative 1.25. So this is what it looks like. I find less than 0.81 like the top one, and then I do less than negative 1, was it 0.25? Yeah, negative 1.25. And then I subtract those values, because if I took the green area and take it away from the red area, I'm going to be left with the area that I'm looking for. So less than 0.81 on my table A is 0.791. Less than negative 1.25 on table A is 0.1056. So when I subtract them, I get the area between the two numbers, and it's 0.6854. So we've gone over how to do less than. It comes straight from the table. Greater than, when we get the number from the table, we have to subtract it from 1. And if I'm between two numbers, I have to do two less thans and then subtract them. So go ahead and try the check your understanding, and only do 1 through 3. So go ahead and pause the video and try those 3. So for number 1, you should have gotten 0.9177. Number 2, 0.9842. And 3, once you subtract them, you get 0.6772. The last thing I want to go over is how to do 4 and 5 on the check your understanding. So since it gave you the percentage and asked you for the z-score, so you would find the percentage in the middle of the table. You have to get as close as you can. It's going to be hard to be exact. And you know what? I think I've got my answer wrong. Hold on, let me change this. All right, there we go. That's fixed. I was at 2%, not 20%. So I find 20% in the center of the the table. I'm going to have to get as close as I can. This is 20.05%, and that's the closest number. And if I go to the left, I get the first decimal place, and if I go to the up, if I go up, I get the second decimal place. So this falls at negative 0.84. So my z value is negative 0.84 at the 20th percentile. So go ahead and try number 5 on your own, and then we'll go over it together. So the fifth one asks for 45% of all observations greater than z. Well, since the table is less than, you don't need to find 45%. You have to actually find 1 minus 45%. So you're looking for 55%. So that would be right there. 0.5517 is as close as you can get to 55%. So the z value is 0.13. So z equals 0.13. Go ahead and jot down any questions you may have from this video, and we will go over these tomorrow in class. Thanks.